Audible? Everyone, am I audible? Good evening. How are you all? Uh, 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 we were looking at the concept of quicksort, right? Today we'll learn about the quicksort. Mm, where it is? Just a minute. All right. Yeah. How are you all? I'm good. No, Nilanjan, I'm not tired at all. Actually, I had a hectic day, but I'm not tired at all. Okay. So, huh, bolo. Any doubt, anything that you want me to discuss in this particular class? Otherwise, we'll start with quicksort quickly. Quicksort part one. Oh, okay, I forgot to connect my tab today. Just a minute. Hmm. So yeah, in the quicksort, basically till now we have learned one advanced algorithm and one basic algorithm from the previous sessions. Yes or no? Right? In the advanced algorithm, we have learned about the merge sort till now. Okay. Today we will learn about something called as quick sort. Quick sort, I can say like it's another type of algorithm. It's easy than merge sort, I'll say, in understanding part also and in implementing also. Like both are the same. You will also find a lot of similarities between them, but all in all, I anticipate that you will find this as bit easy. So should we start? Should we start with today's session? Everyone, yeah, today's Friday. Show some energy. Okay, ठीक है, चलो. All right. So in the quick sort, it's also one kind of algorithm. It is also one kind of algorithm for divide and sort. Remember, in the first class only, I told you everyone that divide and sort is a class of the problems. Okay. So there are many problems that, and there are many algorithms that are based on this particular concept of dividing and conquering. Okay, divide and conquer, not sort. Okay. Also, one kind of algorithm of voice breaking. Everyone, for everyone, students breaking. Just a minute, let me check. Is it audible now? How about now? Fine. Okay, chalo. Huh. So we were telling at the concept that this divide and conquer is also one kind of algorithm which is based on, sorry, quicksort is kind of algorithm which is based on divide and conquer thing. Okay. So in the first class only, I told everyone that this is nothing but a class of problem. You remember? It's nothing but a class of problems or questions. Again, disturbance. think to platform. How about now? How about now? Am I audible? Like once I'm sharing the screen, still it's there. Just a minute. I'm changing my mic. Okay, I'm changing my mic to AirPods. Just a second. Then tell me how it will be over there. Wait a second. Am I audible now? Am I audible now? Everyone, is it fine? Okay, chalo. So once again, I'm starting from the beginning of the things. I hope I'm audible still. Okay, because I'm sharing my screen now. I'm audible. Clear for everyone? ठीक है, चलो. I have changed my mic. Okay, no problem. Uh, Fine. So I was telling you that this divide and conquer, it is based on what? It is, I told you in the first class only that this is nothing but my class of problems. So there are many problems and there are many algorithms, which is based on this particular concept of dividing and conquering. Okay? So quicksort is also one kind of algorithm which is based on divide and conquer. Okay? Till now, I have just told you this. Now, it is works on like this algorithm. What is new about this algorithm? It works on the concept of partitioning. Okay, the concept of partitioning. Now, what is partitioning? I'll tell you in a while, but this is nothing but the heart of this algorithm. Okay, heart of this quicksort algorithm, which is not partitioning. Okay, so you might also relate with real-time example with this. First, let's understand about the partitioning. What do I mean about the partitioning thing? Okay, fine. Okay, so now what do I mean about partitioning is, first of all, we have to select our element in here. Okay, let's say for an example, I have this array. Let's say for an example, I have this array 1, 8, 3, 9, 4, 5, and 7. This is nothing but my array. Okay, so in here I need to select an element first of all. Okay, let's say first of all I need to select my element, that is something called as pivot. Okay, okay, so we first of all we need to choose a pivot element. Now pivot is what? Like you can select any element as a pivot element. Okay, any element from this SPI as your pivot element, but most probably in, like I can say 99.99999% this will be our pivot element in every cases. Okay, fine. This is just for assumption. Okay, you can also select any element that you want. Fine. Okay, pivot element is any random element from your array. Fine. Now, so here I have taken this as my last element. You know? My last element is nothing but my pivot element as of now. Joseph, it is my advanced algorithm, and Nishant, just wait for a minute. I'll also tell you it in this, like what do I will use in this. Okay, first of all, just understand the concept, then after we'll figure out what we need to use it. Okay, how do we solve it? Now, I will place this 7. I'll place this 7 in such a way that I'll place this my element of 7 in such a way that every element which is less than 7 that they will come here. Okay, so basically here my every element will come which is my less than 7. Okay, in this part, this will be my pivot element, and in the right side of thing, in the 7th right side of thing, every element which is greater than 7 they will come here. So pivot, after doing this particular pivot operation, you will feel that 7, your pivot element, after each and every operation, your pivot element will come at its position which is right for them. and every element which is less than 7 will come on the left, every element which is greater than 7 which will come on right. And ideally it is correct also if you are working in sorting algorithm, right? If there are any element, if there is any element, then that is all you need, right? Because if you select any element from this, it should be in the right position. Okay, so consider that if you apply this thing in each and every element, don't you think so that every element will come at its right position if we work in the right way? है ना? Okay, this is what our pivot element is. So for an example, in this particular case, can I say that every element is less than 7? That does mean what? Here I can have 1, 3, 4 and 5. This will be my left half of this pivot element of 7, and in my right thing, can I say that I will just have 8 and 9? This will be only thing which will I have in my right. Can I say that? Can I say that? Okay, so now let's take another example of this. Okay, let's take another example. In this particular thing you will be much more clear. Okay, let's take another example. Let's say I have 9, 4, 3, 6, 2, then I have 8, 1 and 7. So as our thing, like this will be my pivot element. I'll choose my pivot element. So like, can I say that my pivot element will be this? Every element less than 7 will come on this side. Every element which is greater than 7 which will come on this side. So can I say that here I'll just have 4, and you have to maintain the relative order. Okay, you don't have to sort entire thing. You just have to mention in the relative order what is given in the question. So can I say that it is nothing but my 4, 3, 2, 6, then also I can have 1. This will be my left thing. In the right thing, can I say that I will have 9 and 8 only? Yes or no? Right? Can I say that element before 7 may or may not be sorted? Element after 7 in this array, 7 is at its right position. I can patch that. Yes or no? Everyone agrees with me? Again, noise. How come? Like I think there must be some issue with I have connected my headphones also. Let me try to use my auxiliary. Just a second. Am I audible now? Am I audible now? How about now? My voice is clear for everyone. Low voice. Still it's low, or it's okay? Clear? I did nothing. I just refreshed my page. Okay. Good. Okay. Just ping me out if you feel any issues with this, because I don't know what is the issue with the platform or what. I don't know. Good now. Now it's good. No noise again. Now, how about now? Fine now. It's fine now. Okay. So I said that it's little bit, it's little low. यार, क्या हो रहा है यार? Okay, we are just checking for final time. Is it okay now? Okay, do one thing. Just give me 2 minutes. Okay, give me 5 minutes. Am I audible now? Still it's there. I don't know what is the issue, man. Just a minute. Just give me a moment. How about now? Is it okay? Fine now? Clear? Eh? I did nothing. I just joined from another browser. I think just like I don't know what was the issue, but anyway, let's start. Let's not waste much time. Okay, I hope it's like everyone for everyone it's clear. Correct? For everyone it's clear. Okay. So we were saying that we had this thing 4 3, like we had this array, right? In that we selected this as my pivot element. Yes or no? Okay. So in that I selected this as my pivot element. So can I say that this pivot element will be here, and everything would be on the left would be having less than 7 element. Everything would be on right will be greater than 7. Correct? Eh? Right? As per our thing. Okay. 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 So see, this might not be unsorted. This might also be not sorted, but this is in on my correct position that I can bet. Yes or no? This is on my correct position. I'm not worrying about this. I'm not worrying about this. Okay. Nishant, I'm just maintaining the relative order of this. Okay. So if you see in this, I have 4 first, then 3, then 2, then oh, I think so. There is mistake here. Okay. That is not 6 here. That is 6 and 2. Okay. We have to maintain the relative order of this. 6 and 2. Now it's okay. Clear? My voice is clear. I think so. And now it should be clear for everyone. Okay. ठीक है. So, huh. So after that, what I will do that what I did till now, I just selected a element which is my pivot element, and then after I did sort that I can say like I did partitioning my elements in that based on my pivot element. Now, can I say that this is my bigger problem now? So can I say that this will be my pivot new pivot now after solving this? So this will be my pivot now. So can I say that if I select 1 as my pivot, so can I say that everything which is less than 1 would come on this side, but there is nothing which is less than 1, right? So it is nothing. Can I say everything which is greater than 1 will be come on this side? So can I say that it will be nothing but 4, 3, 6, and 2? Clear? Clear, people? Fine. Okay. Now, here my pivot was 1 and all element that I selected was less than 1 in the left side, greater than 1 will form 2 sub arrays. Okay. So it has formed 2 sub arrays. Now, although here it is empty, but it has formed 2 sub arrays, right? Okay. Now, can I say that this same thing applies on my right side also? Can I say that this will be my new pivot now, right? Hannah? So can I say that everything like this is my pivot? Okay, everything which is less than 7 would come on this side, but there is nothing which is less than 8, less than 8, not 7. Okay, sorry. So in that thing, I don't have anything which is less than 8. I have one thing which is greater than 8, so it will come on this side. Clear? Clear? Nishant, we did not do anything randomly now. See what we did. First of all, we selected this as my pivot. है ना? Then everything which was less than 7 was like pivot. We can select any random element, but for simplicity purpose, you remember that every time we will take this as my last element only. Okay? Fine. But you can mention, you can select any element as your pivot element. Based on that, it will, this subarrays would form. Basically what my pivot element does is, after this partitioning, your pivot element would come on its right place. It will not bother about which is less than this, which is greater than this. It will come on the right position. Clear, Nilanjan? So you can select any element on your of your array as your pivot element. Fine. Okay, so I did partitioning. I did apply my partitioning algorithm on my 9 and 8 also. So now can I say that, see, after that, after I did this particular 1 4 3 2 6, and I selected 1 as my pivot, and I got that. I selected 8 9. I selected 9, sorry, 8 as my pivot, and I got 8 9 as my sub array. Now this is my single array. So can I say this is nothing but my base case as like merge sort only? You know, this is my base case. So I'll not do anything on this. 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 Now remaining is what? 4 6 4 3 2 6 only. You know, this will be my main big problem now, because everything which is divided, which I partitioning, they are divided on subarrays. You know, right? So can I say that here this will be my new pivot now? This will be my new pivot now. Fine, है ना? ठीक है? Yes or no, people? ठीक है? Okay. So if this is my new pivot, then can you tell me that which will form on my left array? Which will come on my left thing? Okay, so do one thing. Okay, so okay, see, this is the simplest problem I have given you. But instead of that, if I do like this, just a second. Instead of this, if I do like this, here it's 2 and here it's 6. Okay, so can I say that this will be my 2 and 6? 2 and 6. This will be again my 2 and 6. And 6 will be my pivot. Yes or no? Everyone is with me till now? Everyone is with me till now? Okay. Now tell me that if I select this 6 as my pivot, what will be in my left? 4 3 and 2 only, right? And what is in my right? There is nothing. So I'll select nothing on my right. Fine. Okay. So now can I say that, see, where was 7? Yeah, 7 was here. Okay. So I forgot to mention here 7. So can I say that 1 was here, 7 was here, 8 and 9. Okay. Now can I say that further if I do it again, similar smaller array was 4 3 2 6, right? We taken that, and 6 was our new pivot element. So all the element which is less than 7, sorry, less than 6, and all element which is greater than 6 will form the new two subarrays. And in the right side of 8, there were my smaller problem which was 9, but it will act as my base case. So 8 and 9 is resolved. Okay, so we'll not do anything with that. Fine. Okay, so we'll not do anything with this. We'll also not do with this also. Now this is what is my concerned area now. So can I say this is my pivot element now? Correct? Enough. Now, if this is my pivot element, then can I say that everything which is less than 2, which is less than 2 will come on this, but there is nothing which is less than 2. So no, nothing will come here. Now here I have 4 and 3. Correct? Okay? Right? Right. Now, in every division pivot, so if you see now that in every partitioning, the pivot element will come on its right position. So if I want to show you, Then can I say that here it was 1, it was nothing, 2, 4, 3, here it was 6, 7, 8, and 9. So can I say that every element has come on its right position? Every pivot element that we have taken, every partitioning algorithm that we have chosen, they the pivot element is coming on its position, which is perfectly fine. Can I say that? Yes or no? Now, the remaining thing was 4 and 3 only. Okay. So let's resolve that also. Let's resolve that also. So can I say that here my 3 will be my pivot element? So everything which is less than 3 will come here. 4 greater than 3 will come here. So can I say that my array is sorted now? 1, 2, 3, 4, 6, 7, 8, and 9. Can I see that? So in the class also, suppose if you are sitting in the examination hall, okay. So you go at the bench to see the number of like your number, okay, where your number is in the examination hall, okay. Now, if I'll say that you need to sit on the 30th number, so what you will do, you will just keep reference of your friend whose number is 25, you know, and based on that particular thing you will sort yourself, you know, based on that particular thing you will sit on correct bench. You will not bother which is on your left, which is on your right. You will come on correct position, you know. Yes or no? Okay. So this pivot element is based on that. Okay, it's like that, it's working like that. Fine. So remember, it is not happening in different arrays. Okay. This partitioning is not happening in different arrays. We are not creating different arrays every time. It is actually happening in the same array itself. That is the beauty of it. Okay. Okay. Fine. Now see, suppose I had this. Now let's say I will have this array now. Just a second. I'm seeing something very interesting now. Let's say I have 8, 7, 6, 1, 0, 9, and 2. This is my array now. Okay. So can I say that out of this will be my pivot? Okay. Last element will be my pivot. So now I'll select this pivot as 2. Okay, here. And now can I say that every element which is less than 2 will come on my left side? It is what? Only 1 and 0, right? Okay. And every element which is greater than 2 will come on this side: 8, 7, 6, and 9. Right. This up to this point, I think so. No, everyone is clear. Yes or no? No? Right. Now can I say that uh in this, if you pick 2, if in this particular case, if you pick 2, then 2 will be my pivot element, है ना? And in the left you have selected less than 2 elements, in the right we have selected greater than 2 elements, right? Okay. So can I say that I can see, can I say that if I'll just write it like this, I have written like this, okay. So this elements will sort itself, so it will be become this, and it will become this and this. Now this will be my as it is elements 8, 7, 6, and 9. Okay, right? So suppose man lo I have something like this. Okay, so now 9 will be my pivot element. After that 9 will be my pivot element, है ना? So 9 will be my pivot element. So everything which is less than 9 will come on left, greater than 9 will come on right, right? है ना? So now we divided our problem in 0, 1, in which 0 was in this 0 was our pivot element, and we have sorted on the basis of that. And in this particular problem, 9 will be our pivot element, and based on that we will sort it, right? But before see right now nothing greater than 9, right? There's nothing, no element greater than 9. So our smaller problem is 8, 7, 6 only. Can I say that? Can I say that if I'll sort this, if I know, if I'll take this as pivot element, then what I'll get here, that nothing, and here this. So can I say this is equals to this? Yes. Here also, that is why I written directly this. Can I say this is my pivot element? Then left side of 0, there is nothing. Right side of this is 1. So can I say this is nothing but this? Right? So on what basis in second step you choose, we will take from left side of right side as pivot element. Nishant, I'm just explaining the concept right now. Okay? How we will do that? Let me come on that in later part. I'm just explaining the concept right now. That here, if you select 9, then can I say that if you select 9, then this is your answer that you will get. Whatever input you will get as your output. Can I say that? Because there is nothing on right side of 9. Correct? Everyone? Okay? Okay? So can I say that my smaller problem would be this now? This only now, because this is sorted, this is also sorted, this is also sorted. It's my base case only, na? This four are my base case. Now my problem is just related to this. Okay? So if I'll just sort it like 0, 1, 2 was there. 6, if I'll take my pivot element, then nothing is less than 6 is there, right? So can I say it is nothing but 8, 7 here and 9 was already there? Yes or no? This will come. है ना? Now if I take this 6 as my, so I had taken this 6, right? That is why I got this particular solution. Now can I say that after that also this will become my smaller problem, because this everything is what my base case is? Yes or no? So if I'll take this, if I'll consider this, then can I say that I will, if I'll take my pivot element as 7, 7's less than element will come on left side, which is nothing. Greater than is one element, which is 8 and 9. Can I say this will be my solution? Yes or no? Everyone is clear now? Everyone is clear now? So everything is happening on the same array itself. We are not making new array again and again to do this process. Clear? Hai? Clear? Concept is clear for everyone. ठीक है. Nazmeen, what's wrong with the concept? Can you say, I'll repeat once again, or can you raise your hand? Mistake? Okay, fine. Chalo. So I will do one thing now, that since we are clear with the algorithm, let's try to write the pseudo code. Okay, let's try to write the pseudo code. Now, if I want to talk about a pseudo code, then can I say that there will be a function of quicksort which will accept an array low and high. Okay. Now inside of this, as per our merged also, in merged also we had the same condition as per our base case. So can I say that if my low is greater than or equals to my high, I should stop. Now where my low will be, where my high will be, I'll say that. Okay. Now after that, what I need to do, I have to just partitioning. I have to just applying the partition algorithm with the array with the low and high. Can I say that? Can I say that? Otherwise, like see, if your low is greater than equals to high, then you need to return. Otherwise, you need to apply the partitioning algorithm till the point of time you are not having the base case. Now, as like the base case is the exact ditto thing as per we had in the merge sort. That is why you will see the same base condition as per our merge sort, because in merge sort also we were stopping when we had the single element. Yes or no? You know? Right? So see, there are many things which will come on this pseudocode, but this thing should be clear with you. Now, there will be a function which will take care of partitioning. That is what my partition function will do. It will take the pivot element and it will return, and like it will partition the elements as well. Okay. See, I'll repeat once again. There will be a dedicated function for the partitioning feature. It will take what the pivot element and it will partitioning the elements as well. That means suppose if you take the pivot element and let's say that element's actual position comes in between of the array, so it will return you where the pivot element is or updated position. Can I say that? So what I just said, that suppose man look, if you have this, right, you are selecting this as your pivot element. Okay, this is your nothing but your pivot element. Now, can I say that everything which is in this part, which is in this part, which will be less than of this, and everything which is greater than this will be come on this part. Now, can I say that if I have this particular statement, if I have made this statement, then can I say that my pivot element is my right position? Like whoever here in this pivot element, it is exactly correct position. No matter it is correct or not, no matter it is correct or not, but this is correct. Can I say that? You know, so it will return you, this will return you the exact position of this element. Clear? Okay, so I'll handle this, I will handle this in my this, that pivot element. Okay, because it is returning me this, right? Okay, now after that what I need to do, I need to apply my quick sort again. Okay, this is the quick sort. I need to apply my quick sort again. Now, whoever has asked, sir, we are using recursion in this or not, they are well smart people that no, they are well smart guy that they will understand this. Okay, because right now we are also using the recursion now. We are calling the same function, guys. Yes or no? Hana? I don't know who has asked, but I think he has got the question. Now, see what I do. This is my low. This will be my high. Okay, right, this is my pivot. So can I say that first of all I need to apply my quick sort with my array, this array, till the point of time my low, and my endpoint will be what, pivot minus one, you know, because this is my point. Yes or no? And after that I need to apply my quick sort array pivot plus one till the end of time. Pivot plus one is this till the end of time. I need to apply this. I need to repeat the process. This is what my quicksort will look like, the pseudocode of that. So we have to know the position of the pivot element because we have to further divide them in left and right. That is why we are doing and we are concerned with this process. That is why I told that this is nothing but the heart of the quicksort. Am I clear, everyone? I think everyone is clear now. Everyone should be clear now. Any doubt they can ask now. Clear? Okay. Now, since this is clear to you, where is the partitioning function? Now, I'll tell you now, Nilanjan, what this function will do. Like, what is code of that? I'll explain. But what it is doing and what is it is returning, that is why that is what I explained here. Okay. Now, how we are partitioning, I'll tell you that. But this part is clear. This part is clear for everyone. Everyone. Priyanshu, Ekta, Dipanshu, Deepak, Ritik, Aradhya, clear now? Everyone? Okay. Chalo. Great. Then I'm just giving you a question. I'm just giving you a question. Let's do a dry run together. Let's say if I have 2, 3, uh, then I have 9, 11, 1, 6, 8, and 10. This is what my question will look like. Okay, this is what my question will look like. Now, oh, just a second, I will then change some values of this. 12 and 3, this is what my array will look like. Now, yeah, now it's okay. Now, can I say that this is my array, then whatever my last element would be will be my pivot element, right? Yes. Okay, so if I want to sort based on this pivot element, if I want to sort based on this pivot element, now first of all let me be clear, let me be very clear with this. Wait just a minute. This is what my pivot element is. Now, if you are starting with the question, then can I say that this is my low, this will be my high, correct? Now, and I will have one. I'll use the two pointer approach now. Okay, in the partitioning thing, I will use the two pointer approach now. Okay, I will have the I pointer, which will rely here, I pointer here. This is my I pointer, and J will start from this till the point of time it is non-ending. Okay, okay. So I'm just writing also that. See, I'm not writing. See, before I pointer, all elements should be. Let me write it, okay, because this is very important. Before I pointer, all elements P less than the pivot element. Okay. So I'll say that if my I is here, then before I, every element should be less than my pivot element. This is what my fundamental logic is. Now I will have the J pointer, which will go from start till the end of the array, right? So can I say that if my array, like if my pivot is this, so can't I say that my let I'll just choose my pivot is equals to my array of height. Can I say that? Right? Okay. So if I can say that, then can I also say that, see, my J is starting from here, ending from here. So can I say that anyway my J pointer would be, let's say I'm starting my J from the low. No, I'm starting my J from the low. J should be go till the point of time my high is not reached. J plus plus. Here, what I need to do, I'm just checking whether my element is less than my pivot element or not. Okay, because why I'm checking that, because this is what my God has said, that before this I element, every element should be less than high. Okay, so I'm checking every element. If it is less than my high, if it is less than my sorry, less than my pivot, then I'll do some operation. Okay, because this is not accepted, है. So what I'll do, that I just do for let J equals to low, J should be less than high, J plus plus, and here I will do that. I'm just checking whether my array of J, that means this everything, na? 2, 12, 3, 11, 1, 6, 8. I am checking for every element whether my array of J is less than my pivot element or not. Okay, this is my pivot element. Okay, if it is my less than my pivot element, then what I will do, I will just increment my I. I'll explain that in detail. I'll just increment my I, and I will do a swap operation with my array of I, which is my increased I, and array of J. This is what basically I will do. Now, what does this mean? What does this mean, guys? Okay. So let's say, let's try run this. Okay. Let's try run this. I'm just copying this. Yes, here. Now, see, I said that instead of this, let me copy this because I can change also here. Fine. Now let's write in this. See, my J is here. Okay, this is my J. Now my J is here. Whether my array of J is less than pivot or not. Now, फटाफट yes no बोलते जाओ. Whether my array of J is less than pivot or not. Yes or no. Yes, it is that, but it is my same element, right? So swap with itself and move on. Okay. So I'll start from this. Okay. This is my same element as my array of j. Okay. Sorry, my 2 is less than my 10, but it's my same element. So I'll swap 2 with it is. So you will not understand in here. So what I'll do, I will increase my j to from here to here. Okay. I'll increase my j from here to here. Now let's suppose like I will not take, so okay, let's take 12. Okay. Now, see where this is, and I'll also increase my I. Okay, you remember we were doing the I plus plus and then swapping, है ना? So my I will be also increased here. Now check again whether my array of j is less than my pivot or not. No, नहीं है ना? So move on, do nothing and move on. So do j plus plus. Whether my array of j is less than my pivot element or not. सही है, वही है ना? So what we will do, do one thing. See, instead of doing the same operation in that, we will ignore that. Okay, I'll tell you that. So what I'll do, I'll just keep my I here only. Okay? I'll not increase my I. So for the same element, we will not consider as of now. If it's needed, then we'll also consider this case, but as of now, consider this. Now since my 3 is less than my 10, then can I say that this condition will be true? Okay. So first of all, what I will do, I will increase my I. So I will be here. Then I'll swap my array of I and array of j. So can I say this 12 and this 3 will be swapped? So can I say that it is nothing but what? I have to just swap it, right? So it is nothing but what? 2, 3, 12, 11, 1, 6, 8, and 10. Can I say that? Yes or no? Yeah. Okay. Now, now. So I had swapped the I and j, and it is correct as well, right? Because everything before on everything before and on ith element should be less than my pivot element, right? Yes or no? Everything before or on my ith element, that is this. Okay, I is right now this, you know, should be less than my pivot element. This is what my concept is, right? You know, so this was my what I'll do, I'll just change on my same array. Okay, so you can also realize that. So I'll just swap this 3 and 12. Okay, right? Now I'll do j plus plus. J will be here. Correct? Okay. Now again check whether your array of j is less than your pivot or not. No, nahi hai? So don't do anything. Just move on. So my j will be this. Yeah, clear till now. Everything is clear. है ना? Now, whether your 1 is less than 10 or not. Yeah, 1 is less than your 10, right? Okay. So do first of all we have to do I plus plus. First of all we have to do what? I plus plus, right? So I will come on this part. I will come on this part. Now, can I say that I have to swap this and this? I have to basically swap this element and this element. Can I say that? Yes or no? Because if you see here, my code, first of all, I was doing what? I plus plus, and I was doing what? Swapping of array of I and array of j. So I'll just do swap my array of I and array of j. So it will become what? My 1 would come here and my 12 would come here. Can I say that? Clear? Okay. Now take the next element. So I'll take the next element. Compare whether your array of j is 6 is less than 10 or not. Nilanjan, what is swap function? We will look into it. Yes, swap is a function. Okay. You can also make it as a function or in one liner also. We'll see that. But just for now, just understand the concept. Okay. How do we derive it? That's not an issue for us, okay? Because if you know the concept, then you will anyway write the code. I have the confidence on all of you. Clear? Okay. Now what we will do, we'll just first of all compare whether my 6 is less than 10. Yes or no? Everyone? Yes. Okay. So what we need to do? First of all, we need to do what? I plus plus. So my I would be pointing to here. Correct? Then I need to do what? Swapping of I and j. Correct? So I'll swap 11 and 6. 6 will come here, 11 will come here. Can I say that? And move the j pointer. J will come here. Okay? Now again check. 8 is less than 10 or not? So yeah, correct. So we will first increment our I. I will be pointing to this point, and then I'll swap the I and j. So can I say that my 8 would be come on this side, 12 would come on this side? Can I say that, everyone? Right? I did the I plus plus and I have swapped I and j. Now see, whatever element that you have sorted, that you have swapped and sorted, है ना, this kind of elements and this also, okay? Because this is my I. So can I say that every element of my I which is less than, like every before I, every element are less than pivot element? This is what we have look into it, right? Before I pointer, all elements be less than pivot element. That is what our motto is. Correct? Fine. Clear? Now, can I say that I need to just move on with the j pointer? So can I say that my j will point to this point now? Right? Okay. Now you actually reach to the pivot element. So you are only execute the loop till the time you are having less than I. Correct? So right now what we have less than pivot element, which is on this part, greater than pivot element, which is on this part. Like see, these elements are what? Less than pivot element. These elements are what? Greater than pivot element. This is what my pivot element. This kind of structure I have made. Yes or no? Right? But what I need to do, this pivot element should come here. Everyone agrees with me? Right? What we have to do, we simply bring a pivot element in the middle, right? We have to make this pivot element in the middle, not in the last. Okay. So after doing all the operation, can I say that I will just do swap operation of array of, see, my I was relying here. So can I say that after I plus 1, my pivot should be there, right? So in my I plus 1, I will swap my pivot element. Okay, not array pivot, it will be pivot only. Correct? Why pivot only? Because in this particular thing, we had taken the pivot. Right? Clear? Everyone is clear? Okay, that does mean that what we had do, what we have done till now. See, our array was looking like this till now. Our array was like this. I'll just copy this. Our array was like this till now. Now what I did, that after this I taken the I plus 1, because this is like this position, right? So what I did, I 2 3 1 6 8, this position is remaining hollow. It is 11 and 12. Now I have moved this high array of pivot or pivot element here in this position. That is what I have made changes in this. Can I say that this is what is required till now? Because everything which is on the left side of this, it is what less than my pivot element. Everything on right side of this, it is what my greater than my pivot element. Can I say that? Oh, yeah, Nilanjan, I'm repeating myself again. See, after we did this operations, can I say that my 10 was relying on the left on the rightmost side, but it should come on the middle? Yes or no? How did 11 come before 12? Let me see. Let me see. Uh, yeah, it will come before 12 only, na? See what we did here. See, I have not no entirely written every steps. That is why you will not able to figure it out. But do you want me to repeat this entire thing again? If you do the same thing, you will realize that this is what your answer. Yes, we are swapping I plus one. No, not 11, not 11. No, 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 no. Okay, I'm repeating myself again. Okay, I'm repeating myself again. Everything I'm repeating. Do one thing. See, if you have this kind of thing. See, till now it is clear. Like till this point, everyone is clear. Till this point, everyone is clear. है ना? Now, what we did here, that our 10, which was our pivot element, was relying on the last side. है ना? It should come on the middle, like in this. Yes or no? Everyone agrees with me? Clear? Okay. Now, can I say that this is my less than pivot element, this is my greater than pivot element, this is my pivot element? So can I say that if I do array of I plus 1, that is what? I plus 1, it is what? 11. And pivot is what? 10. Right? So if I swap both of them, okay. If I swap both of them, can I say that it will be like this? Now it's okay. Now it is okay. Okay. And now the process completes because because of this, the pivot element is at the right position. This you have to do every time in order to sort your thing. Correct? Now am I clear for everyone? Am I clear for everyone? Everybody, Dipanshu, Nilanjan, clear hai? Yeah, I did not see that. I did not saw that. Okay, sorry for that. Okay, clear hai na? Yeah, it is not sorted. So now see what after this phase. This is a pivot element. It is done, hai na? So after that, you need to do the same process here also, same process here also. Okay. So if you do the same process here also, you have to apply the same thing, apply the same scenario like this every time. Clear? This is a partition function, Joseph. This is the partition function. Can you realize that we had reached this particular base case? This is a single element. That is what we have to do every time, like recursion. Clear? Okay? Right? Anna? Am I clear, everyone? Am I clear, everyone? Okay. So I will give you a question today. I'll give you a question right now. You have to solve that. Okay. You have to solve that and you have to tell me what will be the answer. And yeah, before that, just wanted to know, have to choose every element as pivot element. Anand, it is not like that. You have to select every element as a pivot element. Why? Because see, if I select this as my pivot element, okay, consider this as my pivot element, and I'll do it will be here, everything which will be less than this, it is what 1 6, like this. Now consider that instead of 8 you will be having 1 here. Okay, you will be having 1 here instead of 8. So hypothetically, not exactly, hypothetically. So can I say that 1 will be my pivot element? Everything which is on my left will be in my left, and everything like this will be on my right. Can I say that? है ना? So this both the thing which I have explained ना, either 1 होगा, either 8 होगा, which it will be of your extreme case. It will be on your worst cases. In the best case, what is your best case?
you'll be having some middle element like 3. One side you have 12, sorry 2. One side you will have what, sorry 1 and 2. And one side you will having not 1 2 also, 2 1 also, because we have to maintain the relative order. And one side you will have 8 6 and 8. So 3, this both loads have divided, right? Not like this, that one side you don't have anything, one side you are having everything, right? So if this kind of scenario happens, then you are right that every element would be your pivot element. But this is your worst case. This is your average or your best case. Clear? And that we will discuss on the time complexity. Okay, don't worry. But nice observation. Now, I'm giving you everyone a question. I'm giving you everyone a question. You have to solve that, and you have to tell me. Once, please explain pseudocode recursive calls initially. Sure. Okay. This is what my pseudocode will look like. You know? So in that, what we are doing, we are first of all considering my pivot element. We are considering first of all what will become as my pivot element. You know? So we are sure that not that one. Okay, which one? This one, swapping thing. Initially, I was explaining from the initial only. Like what will be a low, what will be a high, that one. You can come on mic if you are, if I'm not getting, okay, if I'm not getting a question, raise a hand, I'll unmute you. Okay, am I audible, Joseph? Hanji, Joseph.
Three lines first pseudocode you explain no, sir. Recursions.
This one,
Yes, 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 yes.
this one.
Yes, sir.
Okay, so what we are doing in this, see, we have this function of array low and high. Can I say that once, see, looking at this, can you say that once this low will bypass the high, you will be done, you are done?
Yes, sir.
Or one, or your low is equals to high, can I say that you are done, because this is nothing but what, your single
Base
element,
case. Yes, sir.
you know, just like merge case, merge sort. So
Yes,
this
sir.
this is the base condition of yours. Now after that you need to do what, your partition condition. Okay, this is your partition algorithm that we have just seen, like this. Every time you have to do till the point of time you are not getting what, low and high,
Yes, sir.
right?
That will be self works.
Yeah, that will be self work. This is your pre
Okay.
self work, not this is, in this case there is no post self work.
Okay, sir.
Okay, clear?
Yes, sir.
Okay.
Thank you, sir.
Any other doubt? Any other doubt anyone have? Okay, can I give you a question? Can I give you a question? Just do this particular thing what we have done here, okay, on your pen and paper. If you do that, then and then only you will be clear, otherwise you will be not. Okay, now but before that, can anyone tell me, like yesterday was your revision session of your merge sort part 1 part 2, if I'm not wrong, correct? How was that? Good. Okay, chalo. Okay, so here what we are taking is, like, I'm giving you a question, I'm giving you a no question, you have to sort your, you have to do this partition algorithm every time, you know. Then after, okay, just do one thing, do one thing. See, I'm with you, together we are doing something else. Let's say if I'm having this 2 3 9 11, then I'm having 1 6, then I'm having 8 and 10. Okay, now this will be my low, this will be my high, right? So can I say that low and high is nothing but what? My marking regions. Okay, I'm just explaining so that you will not forget anytime. This is what my marking regions. I'm just explaining from very basic thing. Okay, this is like this thing we are not supposed to write also because this is like explainable things. But still, whenever you are revising, and don't want that any one of you will be on confusion mode. That is why I'm writing it. That low and high will be my marking regions. My PI is nothing but like it's not a pointer. It's not a pointer, but can I say that it is nothing but my hmm, where my pivot element will store, let's say where my 10 will store. Okay, so in here can I say that my let pi will be my array of high. That does mean what? It is my 10 now, and I will rely on my low minus 1. That is what? Something like here. Okay, okay, and j will start from here. J will start from here, from my low, and it will go until the point of time it is not reaching here. Okay, okay, so it is moving from low to high. Fine. Okay, cool. Now 2 is the element. 2 is the element we saw because j will go anyway from start to end. Yes or no? है ना? Okay, 2 is the element we saw because j will go from the start to end, right? So j will be also pointing to this. Yes or no? Now 2 is the element which is less than pivot also. That means that it is something in the region of I will come. Yes or no? Clear? Right? Okay. So I basically shift by one step an element on I and j index. Okay. So basically what I do, I'll just shift one step here. I'll just shift my element by one step, and I and j index are swapped, meaning swapping at the same position. Okay, so I'll swap to on to only. Then we basically increment my j. Okay, so what I do, see, my algorithm says that first of all you need to increment my I. So for that, what I do, I start my I from low minus 1, right? And if my I is standing here, my j is here, okay, my low is also here, then here my 2 is less than 10. My low is at I minus 1, right? That is what? Minus 1 only, because 0 minus 1 is what? Minus 1, right? So since my array of j is less than my pivot element, can I say that first of all I need to increment my I, right? That does mean that I will also point to this thing. Correct, everyone? Am I right? Everyone making sense? Am I making sense for everyone? Yes or no? Everyone should answer this. Okay. Now my eyes standing here. Okay, Ritik, I'm repeating. Uh, okay. See, I'm doing the same thing once again. This was my 2, right? Okay. This was my low pointer. My j is also starting from 2 to 10. Am I clear with this, Ritik? Yes or no? Now, since I said that every time, if your array of j, that does mean this pointer, this element, if this element is less than this element, then can I say that first of all, I need to do I plus plus, then I need to do swap of array of I and j. Yes or no? Okay. But the problem here was, as per our previous scenario, hai na? In this also we had faced the same scenario, same problem. So for that, as a resolution, what I did that my I pointer will now starts from low minus 1. That does mean what? in this particular position. Okay, in this position my I will rely on Ritik, correct? है ना? So whenever you are having the same scenario, that if your array of j, which is your first element, which is less than your pivot element, then you will stick to your algorithm, which is what, I plus plus, and the swapping of array of I and array of j. So basically, first of all, if this is your case, then your I will be first of all incremented. Now your array of I is at 2, array of j is at 2. Can I say that you need to swap at the same position? That is what? The self swap. है ना? Nilanjan, I am explaining that only, na? That we had a problem. If we are starting I from here, then if I am having this scenario, then can I say that if I am starting I from not low minus 1, if I am starting from low instead of low minus 1, that is what, at the starting position as j. है ना? J is also starting from low. So if this both things are starting from the same thing, can I say that if this thing is less than this, like this is my scenario, like this only, can I say that my I will unnecessarily be incremented, and this 3 and 2 will be swapped? So basically it will form like what, 2 3 2 9, this kind of thing it will form. It is wrong. है ना? That is why as a solution I thought that why don't I start my I from here only instead of here. Now clear everyone? Okay, we had the problem of I of the first element, we solved that. Now uh okay, now rest of the thing would be as it is. Now you need to tell me, and you need to do a dry run on this. You need to do a dry run on this, and you need to do uh one more thing. Okay, just a second, I need to tell you something else also. Okay, so this step is clear now. This step is clear, the self swapping. Yes or no? Hariharan, we are just doing for one operation. Okay, if like, let's see in the code, if we have to eliminate that, we'll do that. Otherwise, just consider that this is one kind of solution. Okay. Now after that, can I say that in after this particular condition, can I say that my elements will look like this? In the previous it was maths, that is why I'm writing it again in a cleaner form, like this. I will have, okay, this will be nothing but my high, this will be nothing but my low, na? And after doing the self swap, this will be again my I also, okay, and my j would be incremented because my high had done with this position. Now with this particular parameters, everyone is okay. This is what I will have now. Everyone is okay till now, right? Yeah. Okay. Now since this is greater than my pivot element, this is also my pivot element, है ना? Since my 12 is greater than 10, so don't do anything, just increment my j like this. Okay, guys, you want me to write entire steps, like you want me to like draw entire steps, so that whenever you are reading it will be easy for you? If that is okay, I'll do that also. Okay, fine, chalo, I will do that. So my j was here. If my 12 is greater than 10, if my 12 is greater than 10, then you need to do nothing. Okay, no steps, or else I can also say like move on. Okay, so I'll just copy the same thing. I'll just copy the same thing like this. I paste this here, and this is not this thing. After that, since my 12 is greater than 10, so I will need to do nothing. So I'll just increment my j. My j would be here. So I'm also writing the steps here. Okay, I'm just doing what j plus plus. Okay, now here my array of j is less than pivot, which does mean that 3 is less than 10. It is true. Okay, so in that scenario, what I need to do, first of all, I plus plus, then I need to do swapping of I and j. You know, basically it's array of I and array of j. Okay, okay. Okay. So now, can I say that? Let me write it in the proper form. Now, if we are doing this much, then array of I and array of j. Okay. Okay. Now, after this, my answer would be like this. So my answer would be like I will increment my I. So my I will be point to this. Okay. And I will swap my 12 and 3. So my answer would be 2, 3, 12, 11, 1, 6, 8, and 10. Clear? You know? No? And which is correct also. Which is correct also, because if you see that your I pointer would rely on this, you know, your I pointer would rely on this now, right? And I pointer will be here, and we are just swapping I and j. So my j pointer would be relying here. So this is correct also, that before I, every element is less than my pivot element. Correct, Anna? Right? Okay. Okay. After that, this is my low. This is my high. Now after that, I'll copy this and this will be my thing. Now check again whether your array of j is less than high or not, or pivot or not. Whether your 12 is less than 10 or not. Oh, no, 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 no. We need to do j plus plus na? Huh, we need to do j plus plus also. Correct? Am I correct? Okay. So I'll do 11 is less than 10, which is false. So I'll increment my j. J will be here. Okay. So my 1 is less than 10. It is true. So I'll do I plus plus and swap function. Okay. Basically, right? Yes or no? Right? So it will follow like this. It will follow like this. So Nilanjan, no, na, because we need to increment I also. Remember, you forgot. Okay. Every time we need to increment our I also, right? So I will be increment to this, and it will be swapped. Got it? So now it will be what? 2, 3, 1, 11, 12, 6, 8, and 10. Correct? Okay. Okay. I would be here. J would be here, but I'll anyway do j plus plus, so j will be here. Now 6 is less than 10, which is true. So I'll copy that. And I'll do follow the process of I++ and the swapping. So it is nothing but what? I will do I++. That does mean this. My I pointer will be on this. And I'll just swap 11 and 6. Can I say that it is nothing but this 2, 3, 1, 6, 12, 11, 8, and 10. I will be on this. J was on this, but it will be incremented. So it will be this. Okay. Again, check. Everything which is less than I, which is before I, it is less than my pivot element. Correct? Tab? True. Okay. Okay. Now, since my 8 is less than 10, which is true. So can I say that since my 8 is less than 10, can I say that I will first increment I and I'll swap this 11 and sorry, 8 was here, no? This was my J, no? Right? So I have incremented my I. J was pointed to 8. So I'll swap both of them. This will be nothing but 2, 3, 1, 8, 12, 6, 11, and 10. I think we did some mistake. We did some mistake. I will be incremented, right? So it will be I++ would be here. Right? So if we swap both of them, 8 will be here. So it is already here. So I'll get what? 2, 3, 1. I think there is some mistake we did or what? Guys, we did some mistake. We did some mistake on previous step, I think so. But you got the point now? You got the point what we need to do. I'll say where the mistake was. Let me find it out. 2, 3, 1, 11, 12, 6, 10. This is correct. Then we did this 2, 3, 1. Here it was a mistake, I think so. Here it was mistake, na? 2, 3, 1, 6, 12, 11, 8, 10. It is also correct. Now at this particular point, okay, got it. Now at this particular point, 2, 1, 2, 3, 1, it was not like this, okay? It was, we forgot us one step only, है ना? Actually, I did not copy that, but I thought that I copied. Basically, we had this 2, 1, 2, 3, 1, 6, 12, 11, 8, and 10. We had this, and I was at this position. J was at this position. Now, can I say that I'll increment my I so it will come on this position? Like this, okay? So it is what my 8, 11, 12, and 10. So can I say that my I will be on this position, J will be on this position, correct? Okay? Now again, if I'll compare my array of 12 with 10, it's not true, right? It is not meeting my condition. Yes or no? It is not meeting my condition, na? Everyone? Correct? Okay? So can I say that my J will be pointing to this point? Correct? Yes or no? Right? Okay. So now, can I say that I have found that all the people less than me was standing before me, right? So can I say that I just need to, like, I know that everyone before this is less than me. Everyone after this is greater than me. So can I say that I will just put myself and I'll just stand it here? Yes or no? Yes or no, everyone? No? Why, Ritik, Hariharan? Can I say no? Like, why no? Yes, correct. Correct. Yes. So that is what the presence of mind. Okay. So this is what my I. So I need to do add I plus 1. है ना? I did not want to do the I minus 1. Correct है? Everyone? Correct? Okay. So it would be here. Correct? Fine. So I have found every person. I have found every person which is less than me from here. So I will just go. I will just go and put myself from here to here, and this will be is true now. Perfectly fine now. This is what we have seen till now. Yes or no? Correct? Okay. Fine. Now, what you need to do now is same concept we apply here. Okay. Same concept we will apply here and on this side. Now this will be become my low. This will become my high. Okay. I'll just get rid of this everything as of now. This will be my low, this will be my high, this will be my new I, which is low minus 1. This will be my new j, which will be working till the I to this point. Okay, same process will repeat till the point of time we are not getting the correct answer. That is what the power of partitioning. Clear? Then which part? This part where we have swapped this 10 and 11. Then second last line, this one. So in that we did not do anything. Na? See, we had this 2, 3, 1, 6, 12, 11, 8 and 10, right? Okay. So now my 8, j was standing at 8 and 10 was this. So can I say my 8 was less than 10? So I had just increment my I. So I will be on this, j will be on this. So I had just swapped both of them. Then am I correct? You getting my point? Guys, am I making sense for everyone? So and the next line also. Okay. This line, right? So in this line, what we did, see, ideally this is not correct, hai na? Because 10 is standing at the last line, at the last position. But 10 should be at some point of time at the position where everything before this 10 would be less than of that. Correct? 9. After that we are not worried about that. Okay, after that what will be there, we are not worried about it. But before 10 it should be the minimum amount of 10. Yes or no? So can I say that if I have followed this rule, that before I pointer all elements be less than my pivot element, if I have followed this rule, then can I say that after the end of the point you can see that my I was at this position? Then can I say that before my I pointer, sorry, my I pointer after swapping will be on this position, right? So can I say that before my I pointer everything is less than my 10? Yes or no? Then, right? So can I say that I have to just put my 10 element here and I have to just swap this 11 here? Correct? Clear? Anyone with any doubt? Anyone with any doubt till now? Clear? Okay. So we will take 15 minutes of break. Okay. In that, you don't have to do anything. Okay. Just take your dinner and come back. I'll give you another question after that. You need to solve in front of me. Okay. That means like you need to solve on pen and paper, just like this. Apply the algorithm. Okay. Apply the same algorithm what we have just applied. Okay. This is what my main algorithm is. This is what my heart is. You need to follow this. Okay. We'll take 15 minutes of break. We will come back at like now it's back at 9. We'll come back at 9:56. Okay, 9:57. Correct है? Yeah. Okay. चलो.
Just checking for the disturbance. Is it still disturbance? I'm just connected with my original mic. Let me share my screen and then tell me. बोलना अभी अभी डिस्टर्बेंस आ रहा है नो ठीक है आए तो like let me know once it is there so I'll remove and I'll connect with my original mic. Okay, now we have seen this, correct everyone? It is fine now. We have seen this in bit detail, right? है ना? Now you what you need to do is you need to solve the question, the same question. Like I'll give you the question, you need to solve it with the help of algorithm that I will give you now. Okay, ठीक है? uh okay, just a minute. uh okay, so you need to tell me the answer for this 8 4 3 6 2 9 1 7. Okay, this is what your question is. I hope everyone is clear with the algorithm. If you want to write the algorithm, I'll give you some time. Okay, take a snapshot. If you want to write, take whatever you do, just do it. This is your algorithm. Okay, and based on this, you need to solve what we have just given in the question. Problem statement is clear for everyone. What is required? Okay, see this for a while. If you want to write this, take a note of this. If you want to take a snapshot, do that. But after that, I'll give you some time to solve the question. You need to do that. Let me know once you are done. So that I'll shift the screen. Is it visible for everyone or like it's too small? Too small? Okay. Okay. Guys, are we done or still working? Okay, no problem. Take your. How about everyone else? They are done with the algorithm. If yes, quickly start working all this on the same way that we did earlier. Okay, try working, like start working on it now. After that, we'll see the code, and then after we'll see the time complexity. And at the very end of the thing, we'll conclude what is the difference between merge sort and quick sort, and then we'll end. I hope everyone has started working on this. If yes, please notify me so that I'll be confirmed that you are working on this. Okay? Once you are done, please put in the comment that you are done or not. Okay? Start working on it now. Guys, how many of you are still working? Yes, Ekta. Because the pivot element should be on the right position, right? Okay, no problem. Take your time. Guys, how many of you are still working? There are 40 people in the class. I can say that approximately 30 percentage of students have answered. How about everyone else? Yes, Ekta.
Hello, sir. Am I audible?
Yeah, audible.
Yes. So like I had this approach wherein instead of taking the last element as pivot element, like trying to take the middle one. Okay. I hope
Mhm.
we can solve it that way also. Hello. 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 Is my voice breaking?
Yes,
Oh.
query. Am I
Okay, sir. So like I was yes, your voice is a bit like like it's there's some disturbance. But hello. So can you try saying something? I'm not sure if your voice is coming or not. Hello? Hello? Hello?
Am I audible now? Am I audible now? Okay, Ekta, you can raise your hand again. I think there was some issue. Oh, I will be 10 minutes of limit, right? Now.
again breaking? Am I audible now? What's wrong today? Okay, so I was saying that Ekta, can you please raise your hand again, please? Please raise your hand again. It is not allowing you. Okay. Okay. No worries. Whenever it is allowing you, please raise your hand. I'll resolve that your query. Otherwise, you can write if you can. Anyone still working? And am I audible now? I think so. I'm okay now, right? Okay. I think there is some issue with the platform. I don't know what, but I'm connected with 5G network actually, not 4G. Okay. So yeah, can we start with the code, everyone? Anyway, can we start with the code? Okay. Any doubt, any doubt in this particular things, any single point of confusion or this kind of things, or you're clear? Everyone. Okay, so let me share my VS Code screen and let me know once you can see that. Just a minute. So I hope everyone can see my screen now. Oh, Ekta has was taking middle element as pivot element and taking 2 pointers extreme point in the array. Hence, I could just return if the array is. Okay. So Ekta, basically, you are telling me that you were starting from the middle, right? As your pivot element, and you are taking 2 pointers as your extreme pointers. But in that case also, by every iteration, don't you think so you will need the swapping thing, because the pivot element should be at the right position, right? You don't know that the pivot elements is right or not, correct? है ना? You will not know that the pivot element is right or not right. So for after every operation, it will be the same what we are doing right now. The only change that you will need to do is on the final thing where we are swapping the pivot element with the I+1. In that you have to make the change depending on what element you are choosing at a middle element. Am I making sense, Ekta? I hope am I clear? Yes, Ekta, time complexity I'll discuss after that. Okay, I'll discuss after the code what will be our time complexity, but it will yes, it will depend which element we are using, but it will depend the value of the element, whether you are, it will not depend whether you are choosing the middle element or the last element, you know. Let's say for an example, if I want to give an example, okay, right now, let's not wait till we discuss about the time complexity. Okay, I'll discuss the one thing. Let's say if I have my array, let's say if I have my array like 5 6, then I'm having 9 1 10 12 and 15. Now think about this array. Okay, okay, everyone think about this array. No matter what element you will choose, no matter what element you will choose, suppose if I'm choosing this element, okay, 15 as my last element, then can I say that after my first iteration, let's say this is my pivot element, okay, everyone in the left should be less than 15. So can I say that it will be what? 5 6 5 6 9 12 10 12 and 1 also, है ना? After 9 it will be 1. Okay, and it will be 15 was will be also in this particular thing. That's correct or not? Correct, है ना? After that we don't need to swap anything, है ना, because 15 is right away, right here also. Then after we'll take 12 because 15's work is over. We'll take 12. Similarly, the same case will happen here. We'll take 10. Similarly, the same case will happen here. In case of 1, we will have some kind of good structure. But in 1 also, everything here would be on the right. In the left, we will not have anything. Okay? Then after we'll take 9. Then after we'll take 6. Then after we'll take 5. So can I say that there will be n number of levels of this? Okay, there number n number of levels of this. For every case, my every element will be will be my pivot element. Yes or no? So it is what it is. We are, if we are doing like this, it is my bad case. ना? For the same thing, suppose मान लो एकता कि आप like your input is like this. In your case, if you are choosing the middle element like 10, okay, suppose मान लो कि if you are choosing the 10 right now, okay, so what will be your case? It will be somewhat better than this. Yes or no? Ekta, है ना? But in that, suppose if I'm passing my elements like this, if you are choosing this element, let's say 0, 1, 2, 3, 4, fourth element, right? In your case, if I'm choosing the fourth element, then can I say if my input like this, then I'm taking 15. Again, this is my bad case. So it is depending on input. It is not depending which element we are choosing. I'm hoping that I'm clear till now. Okay, it does not matter which element you are choosing. It is matter which is my input, है ना? Which is my value at this particular position. That is what is yeah, that's depend on the value. Correct. Now, looking at the code now, let's say ठीक है. See, I am pretty much clear with the code. Okay, I will not write that I have not taught till now. Okay, I will not write that is I have not taught till now. I'll just write whatever I have said, whatever I explained in the English words. I will just write it in the coding terms. Okay, let's say if I'm writing my function quick sort, this will be a function. As we have discussed, it is accepting what? If you look at the pseudo code, it will be array, low and high. Okay. Now here I'll just write my base condition. If my low is less than or equals to my high, then I need to do what? I need to break my thing. Okay. Basically, I will do my break thing, or else I can say it is my return thing. You know? Not break, it's like return. Okay. Not exactly the break thing. So it is what my base case. Just like more sort, right? Then after I will do my partition. I'll call my partition function. In my partition function, I am again passing my array low and high every time. And this partition function, as discussed, it will return me the index of the correct position of my pivot element, whatever I have chosen. Okay, so let's say I'm taking it's not P1, I'll take PI. Fine. And after that, I'm calling my quick sort for array low till the point of time my pivot element -1. Correct. I'm again calling my quick sort till the array pi plus 1 till the point of time my high will not be able to reached. Okay. Okay. This is what my case would be. After that, I will call my partition function. In that, I'm writing array low and high till the point of time I'm hoping everyone is clear. Oh yeah, it will be not less than, it is greater than. Correct. Am I clear till this particular point? Fine with everyone till this particular point. Now we will write the partition logic, what we have discussed in the pseudocode as well. Okay. So in that, if you remember, we were taking our pivot element as the last element of my array. Okay. So array of high would be nothing but my pivot element. I was taking my I as my low -1. Why? You know that. Okay. Then after I'll iterate through everything, every element of my j, let's say from starting from low till the point of time it is not reaching to the high, and every time I'll do j plus plus. Cool. Okay. Now I'm checking my main condition, that entire algorithm is based on that, whether my array of j is less than my pivot element or not. Okay. If yes, then I'll do I plus plus. and I will swap whatever in my array of I and array of j. Okay, so basically see, I have not created the entire new function for that here. And now if you have observed, let me take array of j, array of I. I'll replace it with array of I and array of j. This is nothing but the destructuring thing. We have used that, I don't know how many times, you know, infinite times we have used that, and infinite times you will use that in your programs. Okay, so make habitual with this particular syntax. Okay, this is what my array destructuring. If anyone is not aware about this, please let me know. I'll explain once again, although we have discussed this syntax many number of times. Okay, now what I need to do here, that after this, what I need to do, I have to put my pivot element at the correct position. Okay, for that what I will do, I will just do where my I plus 1, I will swap that position with my array of high. Yes or no? Yeah. So this is what I will do in my I plus 1. Correct? Yeah. And after that I'm just returning whatever my position of I plus 1, because that is what my position of my pivot element. Yes or no? You know? Yeah. After that I will just check it. Let's say I'm passing let array is equals to 4 2 1 5 6 and 8. Suppose this is my array. Now if I'm doing console, sorry, if I'm just calling this quick sort with my array, low would be 0 and high would be array dot length minus 1, and I'm just consoling out my array. What will be my array would be. Let's check if we need to modify or we need to change something in order to get the answer or not. Let's check. Node 0107 quick sort dot chess. 1 2 4 5 6 8. It's correct. Everyone got the pointers? Clear? Okay. So everyone will now do this. Let me do this like this. So I hope everyone can see the code. Everyone can see the code, entire code. Okay. Start working on it. Please do write this on your own. Do not try to copy and paste. Okay. I'll repeat. Do not try to copy and paste. You know the concept. Just try to think what we have learned in the algorithm, then try to implement on your own. Do not see the copy and like do not see the code and copy and paste directly. If you are stuck anywhere, feel free to see. Okay. All right. Chalo. Start working on it. Yes, Hariharan, we will return I plus 1 now, because next time I have to use that. I'm returning that in my pivot here, pi. Next time I will do my sort in my left thing and my right thing, if you remember. Sharath, if you have remember, then see, I cannot do that right now because everyone's flow would be disturbed. But see, that gets into PI. Yes, that gets into PI. But see, if suppose man lo ki here I'm getting my PI. Let's say we have taken the example. Like look at the example what we have taken. Okay, in that example, can't you see that we had the array like 2 3 9 11 1 6 8 and 10, right? In the 10th element we have taken that as my pivot element, yes or no? After that, after my first operation, can't you feel that after my swapping of my pivot element, we had everything on the like whoever is before I was less than my pivot element, that does mean my less than of my 10. So can I say that I need to do my operation now with 2 3 1 6 and 8 only? If you can see the code now, है ना? ठीक है? On that basis, my low would be 2, high would be 8 in that particular point. Just we have discussed. Sharad, are you getting my point? Am I audible? Am I audible?
Am I audible now, people? Okay. So see, let me clear first the doubt of yourself. Okay, there's 2 or 3 people have some doubt in that. Let me clear that first. Then after you can code. Okay. See here. See, the first doubt that was asked by uh, Sharad. Sharad, are you there? Can you please come online? Can you please raise your hand? Could you please raise your hand, please? Mic not working? Fine, no problem. See, I'll explain. See what we had here. This was my code. Okay, this was my code. Okay, in that, see, your question was that why we are doing this, you know, and why we are taking this and why we are doing this, how this is working, correct or not? Okay, so in that, if you see na Sharat, then here every time I'm passing this I plus 1, that does mean what? See, here after this line, what we did, we replaced this here, yes or no? Why we did that? Because I need to, next time I will just need to consider this only and this only, yes or no? That means whatever there in my this position and this position, that does mean what? Now if you see the code, that means you can clearly see here, you can clearly see here that p minus pi minus 1 and pi plus 1, yes or no? So that is why we are returning this I plus 1 from here, so that we can use it next time to bifurcate this and this left and right tree. Okay, left and right partition, not tree. Both of them, are you clear? Sharad and Hariharan. Clear? Yeah? Fine. Chalo. Now I'm sharing the code once again. Continue your work, everyone else. Okay. Now after you're done, then after we'll solve any doubt is come. Okay, I'll not disturb you. Okay, work on it. I'm waiting. Yes, sure. Correct. Priyanshu, I can paste the code, but see, I want you everyone to write this on your own. I do not want to copy and paste. Okay. Guys, how many of you are still working? Please share the status. You're work in progress, or you're done working? Okay. Take your time. Okay. Are we done, people? Are we done, guys? Everyone? What's the status? Okay, chalo. So we'll start with the time and space complexity now. Okay. Just let me. And yeah, guys, do not try to copy and paste. I have seen some basic mistakes in like those problems, like who have said in the chat section. Try to code as per your understanding. Okay. Do not try to copy and paste. That's what I say. It will be not beneficial for anyone. Okay. Fine. So, if I want to discuss about its time and space complexities, let's say if I have a question, like uh, 5, 6, 9, 1, 10, 16, not 16 actually, I have like 12 and 15. This is what my question is. So can I say that I will take, as discussed earlier also, I will take this as my pivot. And if I'll take this as my pivot, can I say that if I sort this, my 15 will come here and rest of the element will be as it is. Then I'll take this as my pivot. Okay, I will take this as my pivot, and see, after swapping by this will be my one array, this will be my second sub array. Yes or no? Now, if I again do partition on this will be my one array, this will be my rest of the thing. Now, if I do again this, then every elements will be partition from this. Okay, so can I say this is nothing but my n length, you know? There will be my n layers or n levels on of this, correct? Right, everyone? Okay, so if I have this kind of thing, then can I say that my time complexity for this, let's say if I form my recurrence relation, then it is nothing but what? P of n minus 1. Let's say like first of all I had this, I segregated my first element, then I segregated second and third, then I segregated another one. Yes or no? Hai. So can I say that this is nothing but my T of n minus 1 plus T of 1 plus T of 1 for this, है ना? Plus order of n, this is for my partition thing, just like my merge sort. Okay, this is nothing but my partition, right? Okay, so this will be your recurrence relation, and if you try to solve this now, if you try to solve this, you will realize that it is nothing but my order of n square. Okay, okay, do try, do give it a try. It is pretty much simple. We have also, like, I think so we have done this. Okay, try to solve this, it will realize that this is nothing but my order of n square. Okay, Hariharan, what I was saying that if you have this kind of array, and if you are taking this as my pivot element, this will be my segregated element, this will be my second my main big problem. Now again, one element will be segregated from this, and this will be my bigger element. This, can I say this is nothing but my n length, है ना? Okay, so every time if I want to just generalize it, I am segregating, I'm removing my one element from my array, you know? That one element will also have its own time composite, that is T of 1, and this is order of n, this is for my partition thing. So if you solve this by substitution method, you will realize that this is nothing but my order of n square. Okay, now if I want to talk about some good cases of it, okay, so let's say if I have my array like this, like 5, 10, then I'm having 1, 12, 6, then I'm having 11 and 9. Now consider the case. Can I say that this will be my pivot element? So if this is my pivot element, then can I say that in my left thing I will have 5, 1 and 6. In my right partition I will be having 10, 12 and 11. Can I say that? Yes or no, everyone? So can I say that my load has been divided equally? It was not there, it was not like that here. Load was only for one kind of tree here. Correct? Okay. So can I say that here, first of all, and yeah, again, if I am considered here like 6, okay. So anyway, 6 is not having anything on right side, but it is having in the left side, it is having 5 and 1, right? 6 is separated. Now I'm having 1 like this. Okay, this will be my thing. But see, I have divided my topmost subarray in the two thing. Yes or no? If I again like do this, 11 will be here, 10 will be here, 12 will be here. See, okay, again I have divided in the equal parts. Okay, so there are equal possibilities here. So can I say that if I am having my like if I'm having like n numbers, okay, suppose if I am having my n numbers, first of all it will divide in n by 2. This will also divide in n by 2, correct? This n by 2 will further divide in n by 4 in n by 4. So what the time complexity of this by just looking at this, not the time complexity, but what will be the recurrence relation? My T of n would be what? First of all, first half, this is my second half. So can I say it is nothing but my T of n by 2 plus T of n by 2 plus order of n for partitioning. This is nothing but 2 T of n by 2 plus order of n for partitioning. Correct? You know, this is the same way what we have derived in our merge sort, if you remember, if anyone have revised the thing. So if you realize that it is nothing but my order of n log n, this is the same recurrence relation or similar recurrence relation as we had in our merge sort. Okay. So your time complexity, here in the best case, in the worst case, and in the average case. Okay. So in the worst case, it will be order of n square. In the best case, it will be n log n. In the average case, it will be also n log n. Okay. Okay. Now, if I want to talk about the space complexity, okay, the space complexity. Now, the space complexity is again, Deepak, we have just discussed now how it is n square. See here, we have just discussed about this, right? I'll explain again for you. Okay. Now, that's why I say that please people try to focus on the things. We have just explained about this. Anyway, see, Deepak, can I say this was my array? Yes or no? In that, can I take this as my pivot element? Yes, no? Deepak, right? So if I take this as my pivot element, then can I say that my left only partition will be done on my left thing because I don't have anything greater than my 15? Okay, 15 will be my base case, correct? So now again, if I want to talk about in my 12, if I want to tell, if I'll take this as my pivot element, then my 12 will also be like this base case. So can I say there will be n layers of this? Every element would be anyway will be my pivot element. Yes or no? Deepak, approximately. So can I say that on an average, it will take T of n equals to T of n minus 1 because in every time my one element would be removed from this. That is like this T of 1 and order of n for partitioning. Okay. So if you solve this recurrence relation, you will realize that it is nothing but order of n square. Okay. Try to solve this equation. We have done this multiple times. Okay. Now, yeah. Okay, cool. So now if I'm talking about the space complexity here, then in the space complexity again, if I have told you that I'm taking n by 2 calls every time. So space complexity is what? This is my call stack. Number of time my calls would be appended here. So if I have n by 2 here, then what will be my space complexity? It is obviously log n. Yes or no? Because every time it is doing half. Yes or no? Right? For n numbers, I am having n by 2 calls. Yes or no? For best and average case. And in the worst case, it will be the order of n only, but for on an average, it will be log n. Okay. So I'm just, if we are doing just averaging, it will be the order of n. Sorry, log n, not order of n. Okay. Yes, Joseph, we are not taking extra array here, but every time my calls would be appended. For n, how many calls would be there? N by 2 calls. Can I say that? Okay. So that is why it is what log of n here. Joseph, that this is discussed in the basic class, that whatever how many number of steps we have taken in our call set, that is equivalent to space complexity. Yes or no? Yeah, it is log n. Am I clear, Joseph? Cool. Okay. Okay. Now, see, in the merge sort, we also have seen somewhat similarity between in this, right? So yeah, one more thing. This is not my stable algorithm at all. I cannot tell this algorithm is stable. Right? Now, if I will find out some similarities and differences between merge sort and my quick sort. Okay. So in the merge sort, in the batch case, what was my time complexity, everyone? In the batch case, in the merge sort, what was my time complexity? Guys, in the previous class only we have discussed this. This is not expected from you. N log n, correct? Right? Speak up. You know, in the worst case, what it was? N log n. And in the average case, what it was? Again, n log n, right? And we have just discussed in the quick sort that in my best case, my time complexity is again what? N log n. In the average case, it is what? N log n. But in the worst case, there is a huge degradation here. It is what? N square. Okay. So here it was n log n, it is n square. Which is better from n log n and n square? For if you are concerned about the time complexity, then obviously merge sort will perform well, correct? You know? And in the space complexity, what was the space complexity for merge sort? Order of n, right? So it was order of n for merge sort. Now here if you are seeing that in my quick sort there is log n complexity. Now if you are concerned about the space, then obviously quick sort would be better. If you're concerned about the time complexity, then obviously your merge sort will be better. So depending on the use case, you will decide which algorithm you have to choose. Okay. Now again, see, in the merge sort we have seen something like we were taking, like, how many recursion calls was there? Okay, in that we had recursion call order of log of n, you know, in merge sort. Yes or no? And in the extra space we were taking, how many extra space we took? We took order of n only. Okay, forget about this now. We have taken extra space of order of n, correct? Right? Okay, in merge sort. But here if you have seen here, just a second, what was that? Yeah, just a second. Now if you see here that what extra space that you have taken here? Nothing, right? So extra space would be what? Nothing, order of 1, है ना? But your space complexity is order of log n because your recursion calls they are order of log n. ठीक है? So this is all about this is all about your quick sort theory, or we can say like everything, like coding thing and all. Now there is again another thing that is called as like I forgot the name of it, but anyway we will discuss tomorrow. Like I remember that. See, tomorrow we will discuss about the quick select algorithm. What is quick select and why we are using it, and what advantage is provided it is providing us to use this kind of thing. We'll again see the exact difference between merge sort, quick sort. Okay, we'll also compare this quick select with some other algorithms as well, and together with we will also like if time permits, then we'll solve some questions related to that. Am I making sense, people? Today's session was I think so it was not that much of heavy that we are used to take up, है ना? It was bit easy, I can say very easy, है ना? ठीक है? दीपक, Dipanshu, Ekta, Nilanjan, Ravina, everyone is clear? Okay, if any doubt is there, please to attend the Sunday's class. They over there you can ask me any doubt. If you don't have any doubt, if you're clear with this thing, do not attend that class. That is perfectly fine. It is totally optional. Okay. Okay, Lekit, what is stability? Can anyone say what is stability? We have discussed this also. What is stability? I think so after in the merge class part 1 or in the previous class of that we have discussed that. Likit, were you there? Yes, same as input. So we have taken the input like so I'm no, I will take another example for this. Let's say Likit, if you have this array 1 2 3 10 5 10, 8, 60. Like this if you are having your array. Okay. Now in the output, after sorting, let's say if I'm taking it's 10A and 10B, okay, for an example. Now after in the output, if you are having the output like this, 1, 2, 3, 10B, 1, 2, 3, 5, 8, 10B, 10A, and 60. If you are having this is not a stable algorithm because this order is not same here. है ना? If my output is 10A and 10B, then it is my stable algorithm. ठीक है? Okay. Yes, it should be having the relative order of it. Now, people, for you, this thing should be clear to you, everyone. You know, this was pretty simple code, but yes, one more time, I'll say that after writing your code, I'm giving sufficient amount of time. Please, couple of time check your code. There must be some minor mistake with it. Okay. Sometimes there will be major, sometimes there will be minor. Okay. If you're not getting output or if you're not getting the proper answer even after writing the same thing, then there is some problem with the code. Then you can ask or you can do anything what you want. But apart from that, after writing the code, just couple of try to debug your code on your own. Will you do that? You have to just write, after writing the code, you have to debug on your mind, like what it will produce. You will realize that there is some mistake in that. I have seen that some people have mistaken in this, some people have mistake in this, you know. There's like minor mistakes. Anyway, this is fine, but just for your understanding purpose, if you are solving your doubts properly, you will be feeling very much happy, you know. Today I think so Likhit and many like 2 to 3 guys have solved another person's doubt, you know. So that is more helping to them also, to others also. So please do follow this kind of practices. And yeah, one more thing, if you are having any doubt, any kind of doubts, please do post on Slack. I am pretty much sure that this people, like in this batch, you will be helping to each and everyone. Okay, there are people who will be helping you if you don't know the things. Try to make a team and solve the problems. Okay, fine. Okay, space complexity for quicksort. So Joseph, can I say that yeah, see here, if I'm having this n numbers, okay, I'm having this n numbers, for every n numbers I'm having for the this n by 2 n by 2, this is also for forming this n by 4 n by 4. So can I say that will be total of n by 2 calls? So number of calls would be what? N by 2. It will be every time it will be what? N by 2, n by 2, n by 2, n by 2 calls would be appended, right? So can I say that together it will form what? Log n call stack operations in your call stack. That is how it is forming its log n. We are going to start a new topic tomorrow. Okay. Ekta, we will solving like you can say, but that is related to the quicksort. We'll learn new concept and some more algorithms related to new quicksort, just like quick select sort, and some other algorithms are also there. Okay, we'll also learn that. Joseph, can you say log of 25 base 2? What is that? Fine. So can I say this 25 divided by 5 number of operation? So anyway, can you relate it with like this, that this log n, you got it now? We have similar kind of problems we did in the time and space complexity, if you remember. Correct? Okay. Chalo. So we will meet tomorrow at the same time, 10 a.m. and we'll solve this kind of quick select algorithm. We'll learn about that. We'll also solve some more problems with that. Okay. On that note, goodbye, guys. Have a great night. And if possible, try to look into it, the notes and all. I'm uploading right away so that everyone can see into that. Cool. Okay. Chalo, welcome.